So we'll start it today. This particular topic is on AIV and FIV, but AIV and FIV, a topic on that, which is a random vibration, and we'll talk about it. What is random vibration, etc. We cannot be having a discussion on a random vibration without touching upon random vibration. Now, random vibration is something which has been covered in detail in my dynamic course. Now, say when I'm formulating a course, I don't know who all will be taking the course on whether they have attended my previous course or courses, etc. or not. So there will be a brief touch up of dynamic analysis, followed by random vibration introduction before we embark into the journey of AIV and FIV. The last session of AIV and FIV will be mostly based on implementation of Energy Institute guidelines. And at the end of the course, I'll share a spreadsheet for all of you to use for AIV and FIV. Even though what I would say is that it's always best that you develop your own spreadsheet, because that way the learning is always complete. But to assist you with this, I will share a spreadsheet with you at the end of the course. Now, the way I've structured the course is like this, that there will be a high level. By high level, I mean that it is not be a very deep one on random vibration, because one aspect of random vibration is associated with vibration measurement, which has been covered in detail in the dynamic course. So that measurement part of it I've kept outside this one, but the remaining part of that course, which was on random vibration, that has been, I've kept it almost unchanged in this one. So we'll start with that one. Of course, the initial start will be on the second bullet point, which is a time domain approach for a single degree of freedom. Now, when we do a dynamic analysis, by that as I will make it clear that do not even think of doing a CZ2 analysis for AIV and FIV, it just cannot be done. But one key concept is very important to understand. It is that when we have a system like a pressure vessel or a piping system, etc., we need to know how multi-degree of freedom has to be addressed. But the multi-degree of freedom is nothing but an extension of the single degree of freedom. Don't worry about if you've forgotten about the term degree of freedom meaning in context of what I'm saying. I'll explain the term, so don't worry about it. Now, that I have not covered in this course because it was covered in depth in the dynamics course, where we talked about the mode participation factors. We talked about the natural frequency extraction, the mode shape extraction. We talked about the modal summation, etc. All these things actually happen if we do an FE analysis for AIV and FIV. But in this course, I will be just providing you with a guideline on if you want to do an FE analysis for AIV and FIV, how it is to be done. But it will not go into detail, simply because that would require whosoever I'm teaching this course have very good grounding in FEA, which you may not have. So if I try to cover it that way, it will not be useful. So for the full audience of this course is concerned, my objective is at the end of the course, and probably it is your objective too, that you are better equipped to understand AIV and FIV and what you can realistically do about AIV and FIV. So after that presentation on general dynamic analysis and talking about random vibration, etc. When we talk about random vibration, there will be a bit of mathematics that will be coming, and that mathematics is just to make you familiarized with different jargons and different terms and contexts that are necessary, not just to perform an FE analysis, but also when you measure some vibration, when you try to solve a field problem, those concepts are necessary. So there will be a section on Fourier transform. Of course, I'm not going to talk about fast Fourier transform, which is an instrument implementation of the concept, because that has already been covered in a separate course. But If you have any questions on that, you can always stop me and ask me, and I'll be more than happy to answer the question. Now, there will be, of course, whenever we talk about AIV and FIV, we cannot but talk about the Energy Institute guideline. So a chunk of this course is focused and centered around Energy Institute guideline. But what I have done in this course is that there's a section which explains to you the background behind Energy Institute guideline. That's how that guideline was developed, starting with the work from Karushi and Mueller, how that thing developed, and what are the alternate things that are there. What is happening in the field of research in AIV and FIV, and how they will be reflected in the Energy Institute guideline. The Energy Institute guideline that is in the public domain till now is still the 2008 edition. There's a lot of work that has been done. The new version that you are going to see will be kind of a significant revamp of the existing one, but that is yet to come in the public domain. And there are a lot of issues behind why it is still not there. But many of the points from that I will be covering in this course. So at the end of the course, we'll be well equipped with what is the state of the art on AIV and FIV. And of course, there'll be some solutions on this. I mean, solutions on the AIV, FIV problems. Now, there are a lot of diagrams and a lot of references are there for the issue of copyright and everything. Every reference where I have taken, everything is stated. All those references are cited. There'll be a box. In that box, the reference number is given.